So we are going to present Clojure, created by James, Daniel, me, and Yude.
You care about me doing one mic because I just dropped it off. Okay.
So up first, we're gonna go over the language characteristics. Then we're gonna move on to the trends of Clojure usage. After that, we're gonna talk about Clojure range of industry usage. Then we're gonna move on to the main language features. After that, we're gonna show a Clojure specific feature example, and we're gonna end off with another Clojure coding example.
All right, so some history about the language. Clojure was created by Rich Hickey in 2007 as a modern Lisp dialect for the Java virtual machine. Hickey designed Clojure to combine Lisp's expressive power and functional programming style with practicality and performance of the JVM, emphasizing immutability, concurrency, and simple composable abstractions for modern software development. So with a little quick timeline in the early development from 2003 to 2007, Rich began designing Clojure to address issues of concurrency and complexity in modern software, within the official release being in '07, as a modern Lisp dialect for the JVM, emphasizing immutability, functional programming, and concurrency, within an expansion happening in 2011 to 2014 on other platforms. Clojure Script for JavaScript and Clojure CRL for .NET extended the language beyond the JVM, allowing developers to share functional paradigms across the platforms. With now modern Clojure 2015 to now, continues evolving with focus on simplicity, data-driven designs, and functional abstractions widely used in data processing, backend systems, and functional programming education. So Clojure belongs to the functional programming paradigm, emphasizing immutability, pure functions, and high-order functions as core principles. It also incorporates elements of the concurrent and data-driven paradigms through features like immutability, data structures, atoms, and software transitional memory, allowing safe and efficient management of state in modern multi-threaded systems.
And over here, there are some trends about Clojure that we have found using the TOV index as well as Google Trends. You can see here that in the next 50 programming languages, going from 51 to 100 in terms of most used to least used, we can see that Clojure is in that range. So while not being the most used, it still has a place within certain use cases in the industry. Also here, you can see in Google Trends, we have web search results for the past 5 years, showing a stronger surge in June of 2022 and the rest of 2023 as well. And then also YouTube search results kind of having a large stagger, but overall not having a large effect. Furthermore, we can see here that Clojure has a range of use in the industry, one of the main ones being data analysis, which is basically how its functional nature and emphasis for immutable data structures really make it well suited for this sort of industry, as well as its particularly expert use case in data mining as well as AI applications. And then additionally, it's also used in web development. It could be used with front end as well as back end services, making it a really prominent choice for this particular situation. And then lastly, distributed systems. As we explained before, the concurrency features and the robust infrastructure make it a very effective choice for building distributed applications. And these are basically the main use cases that you will find Clojure. Furthermore, there are also the main features that are involved in Clojure that make it an important language to know about, including its immutability, as Clojure definitely emphasizes these sort of data structures, meaning that once a value is created, it can't actually be changed, which prevents some of the side effects that you would see in other programming languages that allow for these values to be changed. Additionally, also it's a functional programming language as expressed before, functioning as first-class values and everything like that. Also encouraging the use of pure functions as well as recursion, some high-order functional thought processes in order to actually solve the problems that you would use Clojure for. And then as well as it using JVM in order to run, it can actually seamlessly use existing Java libraries and frameworks, making it a very good language to work in tandem with on Java projects.
As you see here, as Clojure is inherited from the Lisp syntax, it is a functional language that defines a function and most notably returns some type of recursive definition. So in here we have a factorial function that is a tail recursive that at the end recalls itself and decadizes I and would add on to the previous value. So in this next one, we have transducers, which is something Clojure is most notably made for, right? It notably is made for filtering out different concepts and being able to transform information through pipelines, allocating them immediately to some type of component. And this is also used when you use atoms, which allows Clojure to state and keep local states within the application. And when you see here, we have Clojure, we have a filter that maps some data to some hash map in a collection, which allows you to then transduce it, leading to things like before said in data analysis, and where you can map out different data sorts and transduce them to fit your own project.
And here are our references that we use for the project. Thank you so much for listening. And yeah, that's our presentation on Clojure.